Okay, let's start quick today, because I'm already almost 2 hours late. But okay, last time I started working on some cool Blender scripting. I've finally begun to understand how to understand Blender scripting. Because it's like the first time I've ever been able to make like non-trivial Blender scripts without just like resorting to ChatGPT doing it for me. But okay, let's get this guy in here eventually. There we go. Let's get this low. That's about good. Okay, ball tool test. So if you weren't here for it, what I have now, I can do let's get this thing actually. So I can draw vertices, and then I can run it in object mode, and we create walls. And these are little prefabs for performance reasons and all sorts of reasons. And the main things that I want now are the ability for it to correctly determine like how to bridge a gap, like this, for example. And also some better handling of edge conditions. Yeah, because specifically areas like where are the areas? Like this. I want this to actually be up at the highest point, not the lowest point. So basically I have to decide I have to basically for each vertex get all of the edges that connect to the vertex, get all of the objects that are placed at these edges, select the highest one, place the pillar there. Pretty complicated. So I think what I can do is I can use a dictionary, and basically we place the walls in between these points first, and then we go over every vertex. Okay, I'm seeing the vision. I'm seeing the vision, gamers. I understand what I want to do. Let's see. Yeah, let's go to our, what's it called? Wall builder? What are these? I think these are just empty files. Yeah. I was organizing, I just have random notes. Hmm. But okay. What I'll do first, because it'd be probably easier, is basically walls at vertex. This will be what we do. Hmm. Ooh, this is going to be tricky because what I actually need is we need the bound condition. We need to know when we're starting and when we're ending. How do we get the last object of a list, or the last object of a while loop in an elegant way? I'm going to keep the volume of this low. Okay, also, I've been flooded with too many small ideas. I've been working on a Celeste map, among other things. This'll be, but I think I'll probably just wrap this up pretty soon, because it's basically just a strawberry hunt. You start here, you can just end at any time, and then the challenge is figuring out where all the strawberries are. If you dare. But it's not going to be terribly hard, because I'm not actually much of a Celeste player. I played some of the B-sides, and that was about it. Oh yeah, also I have a drink here. But okay. The main thing is getting the dictionary of vertices. My drink is like sliding around. Hang on. This is very important. Okay, now we're cooking. Okay, if placed equals 0, we'll start with the starting one. So like walls at vertex e dot vertices 0. So e is the actual edge. And then we get the index here. And that'll equal whatever it equals. You know, now it actually makes sense that we get, you know, this as an index. Okay, this should be W. There we go. For V in oh. We loop over the vertices now. Can we get the indices of, oh wait, no, it'd be literally just like range. Walls, vertice, or what would it be called? obj.data.vertices. Length? No, len. Oh wait, can't we just do like IV or something? And this would be like enumerate. Hang on, let's check how this would work. Our first line of defense in the world of ignorance is the Python console. So if we did c.activeObject, we get our little thing. And so what I'm looking at right now is data vertices. And I think what I can do is IV in c.data. Let's say enumerate. Actually, let's just do enumerate here. Okay. Print. Oh, typo. There we go. Okay. Okay, so that gets us our indices. So if walls at vertex V, or let's say if V, or if I in walls at vertex, let's see, where do we place the pillar? We're just going to do this now. Actually, do we use the pillar here? Like anywhere in here? I thought we did for some reason, but we don't need to now. We just do this. And we'll have highest point equals V dot coordinate. And then for I in walls at vertex, if, oh wait, no. Let's say wall. No, a wall list. No, this has to be this actually. For wall in walls at vertex I. If let's just say highest point dot y equals max highest point dot y wall dot location dot y. So now we should get the tallest point at each location for each vertex. And if there's only one object placed there, so now the last thing we need to do is if this, I have an idea. Or like, go equals true. While go equals cover distance plus that less than run. If not go, then we do walls at vertex e dot vertices 1 equals w. And actually, it works if both of these are true. But okay, so now we basically just have, we detect the last object there as well. It'd be nice if there was like a finally block for while loops, I'm realizing. That'd be an interesting thing. Where like it has all of the same variables in scope. Oh yeah, true. It did not quite work because p is not associated with a value, which makes sense because there. If not aligned, p.location.z equals w.location.z. Aligned equals true. Oh, right. I see. This used to be where I did all that stuff. So now we don't need the aligned variable. Walls at vertex. Oh, right. We need to do dot append w. Okay, how do we actually do this? So like def add wall I w. And let's just say like D. Or like dict array append. So like if k not in dictionary, oh, let's say dk Donkey Kong equals an empty array, and then we do dk append w. And then instead of doing this, what we do is we dict array append. Like this. And we just do the same thing here, except we do one. Okay, so I'm not seeing substantial improvement. Also, for some reason, these walls are like a lot lower than they're supposed to be. Because like we can see this here. Like clearly these aren't in the correct position. Was it just like what was that? Like why did it like behave differently? Huh. Interesting. I don't get it. Huh? How is it editing the array? That doesn't seem right. Oh, I think we're getting a duplicate. Let's see if this works. I I don't know if that works. But yeah, I think vectors are actually like a reference type. Like they have a tuple inside, and then if I edit them, they like the same thing. But okay, it's kind of working, except for the pillars are in the wrong place occasionally. And I think that's because it's weird and confusing. Because yeah, if you look here, if you'll examine Exhibit A, they seem to be in the wrong place. But I think it's mostly because these walls go way too far. Which actually, okay, I see. And that's because we need to have this not here. I see. Because this is at the start of the array. You know, let's just do like last placed. Let's not fiddle with loops too much. There we go. Okay. So that makes sense. Now the pillars make sense. And so you can see now they're actually doing the correct thing where it basically chooses the tallest of... Oh, it should actually choose... It should not choose the wall unless there's nothing in here. So we actually need this to be like vector 3 or vector 0, 0, 0. Or v.co.x, v.co.y, negative infinity, if this else, highest point dot z equals v.co.z. Basically, it should only do this if there's no walls there. Actually, it should not do that. It should just do this, and then we can have v.co. something or other. Who doesn't have the pillar property? Wait, what? Oh, I see. That wasn't a scripting error. That was a usage error. Wasn't infinity like a thing that we had? Maybe it's... Hang on. Alphabetize your imports. Yeah, we got decency now. Okay. So now it does closer to what I want. Which is, it puts this exactly aligned with these walls, and it aligns with the highest wall. It's interesting, though. It seems that in various places, it doesn't place a pillar. If I, in walls at vertex, I mean, I guess we could just print. Oh, right. I keep doing that. Oh, well. Okay, where is... There we go. So we have all of the vertices here. Well, almost all of them. Actually, no, yes, all of them. And some of these we don't have the oh, we also need to print walls at vertex. Okay. So that seems to be our issue. Hmm. I mean, let's just print K. Okay. Is this like printing? Am I doing something wrong? No, this seems like it should work. Oh wait, did I accidentally add an infinite loop somehow? Because now it's like not running. Now it's frozen. What did I change since the last time? I guess the enumerate walls at vertex. Maybe enumerate doesn't work with dictionaries. Hmm. Wait, this should be W. Yeah, I think Blender's cooked. Thankfully, we haven't done anything important in it. And that's also the advantage of editing in a separate text editor, is the fact that like Blender can crash and I don't lose anything. And actually, I was thinking a little bit that it was dumb for me to have this test scene, since I'm just going to use this in like a specific scene anyway. But that's also a good reason for it. It's justified its existence retroactively. Oh wait, I literally did the same thing that I was like, I just did exactly the same thing. Okay, we're probably going to need this here for a while. Oh, interesting. Okay, so it was alive. We don't need this forever. Okay, so I'm going to say we probably don't need this. And we don't really need this anymore. And then... I mean, this is really the thing that I added, though. Oh, well. So something there was the wrong thing. Hmm. So you can see for a lot of these, we only have one option where we have two. That makes a lot of sense. That's how I structured it. Oh, and some of them have three. That's good. And then what I should do is I should print the K. Okay, so this looks correct as well. Am I doing something wrong with this? For wall and walls.vertex.I, because we only have two pillars here. And I guess what I can do is I can do, so we have pillar edge dash, actually we need vertex I. Let's just call it that. Oh wait, but we need these to have the same name as their actual name. So we should just do like plus equals, I know what it should be. It should be equals pillar.name plus vi. There we go. And then we'll do the same thing here where we just do e or w e. Or like, edge this, segment that with our original name. Oh, right. Okay. So now we have the posts named consistently. And that just begs the question, why no posts? I guess we just print, or else print skipping vertex I with no walls attached. Okay, so how many so skipping vertex 1 with no walls. So how does this... Why is this untrue? Did I make a... How do we make dictionaries in Python? Am I not understanding this? All right, W3 schools, tell me how this works. Okay, that seems correct. Oh, can we just print the dictionary? Can I just do print walls at vertex? I guess it must be a lot of Blender's built-in types can't be printed. Okay, interesting. So it does that even though when we printed everything else, is it because dictionaries are like a value type and they're, or like copy on write or something like that? That would be crazy. Hang on, where's Firefox? Oh, I must have like deleted the tab. Okay. Python dictionaries. Actually, what if we remove this here? And I just do this. And then try this. Because there's something weird with how nested functions work, where like if you assign to a variable in a nested function, it does a nested thing. But okay, we sure are skipping a lot of vertices here. Hmm. Let's do E, E, K equals W. So this is walls at vertex K. Let's say like gets W or something like that. Oh, whoops. Yeah, we can see pretty clearly that we are assigning each and every one of these, and that this is just a different variable than this. I don't understand. Hmm. Okay, so it's always value, I think. Passed by object. Wait, what? So why does this code work? Add contestants. Hmm. Am I stupid? So why is it not working then? I mean, let's just print the whole, let's just print this then. See what happens. See where, what stage is this going wrong? Because we got 1, so we assigned 1, good. And then we assigned 0, so we got that. Then we assigned 0 again. And that must, okay, that is where I'm making a mistake somehow. Oh, if K not in, wait, but that's, it's incomprehensible how that even worked at first. But okay, so like, let's see here. So we add at vertex 1. Oh, okay, I'm seeing the flaw here. This needs to be up at the top. We're inside the for loop for the edges. Wait, then how the hell did the, why were we allowed to reference this object when it was inside of this function? Is it like dynamically scoped? That's crazy. Python's whack. I don't like it very much. But okay, now at the very least, we put the edges, or we put the tubes bits things, and they're mostly working, though I do see this one is wrong. And I don't know how it got this wrong. So something to do with there being 4 of them. Because it works for all of these 2 segments, works for all these 1 segments. Hmm. Oh, and also, I just realized we can do rotation Euler equals we don't even need this. Well, we kind of do. But let's just do like Hang on. Now what we need is... So if not highest wall, or highest wall location dot z is less than wall location dot z, highest wall equals wall, and then what we do is highest point equals vector 3, or vector v dot co dot x, v dot co dot y, highest wall dot location dot z, and then rotation Euler equals highest wall dot rotation Euler, because that angle was not supposed to even exist anymore. I did not realize that Python does not have lexical scoping. That's crazy. It's like we're in, like, I don't even know. I don't know a language that doesn't have lexical scoping. But okay, that really didn't do anything much for us, except, well, actually, did that change much? Okay, yeah. It changed a little. Okay, so this one is the odd one out. Because for some reason, we're choosing the wrong object there. So let's print I walls or len walls at vertex walls. Let's just first see how many walls are attached to what. So I think 4. Oh, right. Well, that didn't quite work. Walls at vertex I. So 4 has 5 walls. That makes sense. Not really, actually. So how do we get... Why do we get... For wall and walls at vertex, print f... Let's do... wall name. So we have E3, E4. We have E3S1. And S0. So that's the only one where we have that. But I guess that makes sense. So E4S0. I see. There's 2 E4S0s. That's not right. Aha. No, I don't get it. The last one here Oh, no, I do get it. Okay, I do get it. This placed should be up here because it's not the number. We don't need the number of walls placed. We need the number of, okay. And that explains why it's so much higher because it's following this one. Also, I just realized I could add the walls into here. Hang on, I'm going to do something fun, which is anytime we add a pillar or a wall, we're going to have like p source wall equals obj. And then if we do this, if source wall in obj, obj equals wall run obj, else and what we'll have here is run obj, or like wall run. There we go. And I'll also add this here to all of our W. There we go. So now they all have custom properties. And that means that now I can just grab this thing, regenerate the script. Not even an issue. It'll just unselect it because we deleted the object. What was I testing for? Oh yeah, basically just to see if the thing works, and it seems to do that. So it's just boom. Beautiful, perfect. So let's put that as like git commit am fix pillar boundary condition. And then we can remove all this printing here. I think what I'm going to do is like a policy is I'll keep the debug printing in like the last PR, even though, well, I don't know. It's good to commit them. Okay, but now what I really need is to figure out the constraint for basically making walls like these work, I think. Also adding pillars here, but I think I can just do that as like placing a pillar. So let's create a function place pillar highest point highest wall dot rotation Euler. And we'll define that up here. So this will be like points rotation Euler. And I guess it doesn't really need to work in edit mode, but I should figure this out. Actually, I'll figure that out soon. I'll ignore that for the time being, though. Place pillar. Ooh, actually, if we're going, we need to figure out if we're going up. So that would be that rise is positive. Yeah, that makes sense. Well, we don't really need that. Okay. I have to use my big brain to figure out, like, what exactly we need here. So, like, if we place a wall here, we're guaranteed to have a pillar because it's the first wall. And so if we have a line like this, you know, we place a thing here, place a thing here, etc., etc. You know, and let's say this is the end. So there's a wall, so there's a pillar placed here, guaranteed. What we need to figure out then is what I can already see is if we are rising rise greater than 1. Oh, wait, no, if rise is greater than 0. So, yeah, if rise is greater than 0, we do not put a thing here. Or, yeah. Wait, no. Place. Pillar. So this will be like, don't we have like the horizontal NH? Okay, NH. So like P. Point is NH times size dot x divided by 2. And this will be w dot location minus this. And the next big question will be, how do we do the last placed object? Oh, I know how we do it. Elif rise less than 0. So for the first object, we place a pillar. And then if we're going up, we place a pillar here at the left side. But if we're going down, you know, so we place this here. What we can actually do is here, we can determine that we should use this or place a pillar here because we have the last placed. Minus size and this isn't super efficient since we're getting the size every time, but oh well. I'm not going to be making like 10,000 walls or like 10 million walls with this. At least not all at once. And so this means that we are always taking care of this point, and we don't have to worry about this point at all. And we always skip it for this one, because we do that here. Not quite. Okay. Wall run cannot access free variable I where it is not associated with a value. Would I do that? Messages, info. Okay, wall builder 194. No, the stack trace is in the opposite order. 110. Oh, that makes sense. So we should have I here. So yeah, let's do like V. Oh, wait, but now we don't have a vertex. Let's have a tag actually here. So it'll just be like PS. Or like S placed. And then for the other walls, it'll be VI. Then like tag. Actually, we can just do plus tag. Remove format there. But okay. So now we can place pillars in two different ways. 3 different ways. 2 different things where we associate it with a particular object. And actually I'll put a unique like identifier here. $191 in 110. Pillar.name plus tag, place pillar. What am I doing wrong? So we get the point, which is a vector. We get the rotation, which is an Euler. And I'm realizing this is still... Is this still... No. Yeah, because we do this at the end, completely separate from the actual edges. Also, I just realized I don't think we ever use... Oh, wait, we do use V, okay. So that's still necessary. I mean, I could just do data.vertices.v, because what I'm thinking is so we could do like I wall in enumerate walls at vertex. Well, no, actually I do need this because it's useful to tell us when a vertex has no walls attached. Oh, it is literally 191. I was ignoring the thing there. If pillar, not an object. Oh, I see. No, I don't see. No, I do see. None type object has no attribute location. So that's at 168. Aha. So last placed should always exist. So if placed is equal to 0, oh, because we need this again up here, we need, yeah, okay. Is there anything else that needs to actually be up here? I think that's the last of it. And so here, we also need this to be here, because we have too many nested loops, basically. Okay. There we go. And now, it almost works. Here, though, it's placing them where it's low. I want them to be placed where it's high. And once we get that working, that'd be great. And then the real challenge will be making this run every frame, which is what I truly want. So that way I can like live preview and probably just eyeball if the walls look good. What's this? Oh, we have 2 pillars. Yuck. Because this one should be over here. Okay. So we are still having some issues, some malfunctions. Oh, wait, I see. This should actually still be our position. So this x-axis. So basically, hang on. Else. Point equals this. And then what we do is we just change the z of the point. We don't actually need anything here. So if rise is less than 0, point equals, so point dot z equals last place dot location dot z. Otherwise, it equals all right, we can actually do, so if rise greater than 0, well, what do I want exactly? If rise is greater than 0, point equals, okay. Oh, wait, hi. Welcome to the stream. I've got pillars working now, yay. Okay, so the issue was basically I was just placing them here by mistake when it was going down or up or whatever I did wrong. So now they're looking a little better. And now the last touch will be the by far the most complicated part, since I'll basically have to throw out most of the logic that I've done for placing them. Where I want it to be, for example, here, I want to be able to figure out where I can place these such that we have them like this and they don't overlap. And then if we can't get them like this, is there some way of like fixing the conflict? Yeah. How do we do this? So I need to like activate my brainstem here. But I guess I can just put inserts pillars between wall segments automatically. So how to adjust the walls? Can you change the length of the path on the go? I could, but I'd like to make it, well, actually, honestly, if it's easier to just make it live preview and like update every frame, that would be good. Because then I don't have to worry about this stuff. So what I'm going to do is, first of all, let's select Blender Python. Delete objects in edit mode. Let's do Blender Python context temp override. What can we override with the context? Area region keywords. So the parameters are window, screen, area region, keywords. When overriding window area regions, we don't need those, I don't think. Wait, no. That's not right. Temp override window equals window. The context override is needed so it's possible to set edit mode. To set the context after loading files. No, wait, no. I don't need to edit there. So I'm going to try this. Basically, because I have here mode object, we're just going to do window equals window. And what this should do is basically mean that I can go into edit mode do this, reload this, run this. It did not work. Oh, great, because we need to do blender.context.whatever. Delete poll failed. Context is incorrect. Hmm. Maybe we just do this. I don't know why it let me do bpy.context.window if that wasn't the thing that was there. Name context is not defined because I have not imported bpy. Yeah, you know what? Let's see if there is a way to set the current mode. Actually, we could just get the current mode. I just realized. bpy.ops.object.mode get? What would it actually be? So if we did c.mode. Okay. Mode equals bpy context.mode. And then what we can do, oh wait, I set it to the wrong mode. Wait, no, we don't even need this, I don't think. Let's test if I just do, because I needed this. Okay. Okay, well, that was easy. Oh wait, hang on. Oh, but it changes to object mode. I don't want that. bpy.ops. Not quite. Okay, thank you, Blender. And also for consistency. Okay, so my mission. There we go. So now I can be in edit mode. I can do my cool thing. We can wibble wobble, wave around, send it, boom. And I don't even need to exit edit mode. And if I select a thing like this and I'm like, hey, I want to move this around and then check this, not quite. Object mode set poll missing active object. Actually, what I can do as well is actually, we can just do this. We don't even need to like fiddle with the thing if it's like we don't need to change the mode unless we're in edit mode. Though I was hoping that was what like the temp context stuff would do. Okay, and now the question, how do we make a script run every frame? Or like run script continuously. A modal operator. A modal operator defines an operator.modal function which running handling events until it returns finished or canceled. Okay. So what I'll do first, get the thing working. What am I doing? No. Run the script in edit mode. Yeah, let's look at what the wiki has to say about modals. It doesn't have to say anything about the modals. How old is this? 12 years ago, you know? Let's just see what Godot or Bing Chilling has to say. In Blender Python, I want to run a script. Or I want to run a function. Every time a mesh changes. Editing it during or such as while editing it. Order to place objects. Vertex. Where would I put such, or how would I structure a function? Just the very basic skeleton is fine. Mesh update handler. Okay. Depth graph update post append. Let's see if this exists. Okay, what is depth graph? What are these? So, basic handler examples, frame change, pre-append my handler, persistent handler example. By default, handlers are free when loading new files. In some cases, you may want a handler to stay across that. Yeah, that's great and all. What are the handlers we have? Drawing and annotation. So on depth graph update, what the heck is a depth graph update? Okay, let's ask Bing. Refers to an update in the dependency graph, which is the system responsible for tracking relationships between different data blocks. Dependency graph ensures that only necessary parts of the screen are recalculated. Recalculates dependencies such as object transformations, modifiers, constraints, and animations. So when the user modifies an object, okay. So can we then check? bpi.context.active object. Okay, so I think what I can do then is we can have the script. So we don't do this anymore and we don't run it manually. We instead do bpi handlers depth graph update post.append our like run, our like wall run thing. Or like wall check. So what does this thing need? Wall check scene. No, we don't need that. We need this. So this will be def wall check. Obj equals this, if not obj, or type not equal mesh. Return. And then we have this, and then we don't need this. We'll just silently return without doing anything. And so that means we don't need our missing... Where was that? Oh, wait, we have full words. Oh, this is all the way up here. Okay. Okay, so now every time we run this initialization, we'll check the scene. And the scene is not something that we use at all. We just check the active object. And that means that we don't actually need this. We can just do if pillar in obj wall run. Okay. So let's see this in action, because now, oh yeah, I forgot. If not obj, or obj type not equal mesh. Ooh. It's getting some issues. Okay, so that doesn't quite work. Yeah, I should have expected as much. The problem is it's not like a thing that runs like once a frame. It's a thing that runs once an update. Like it's not even doing anything. Like, huh. Wait, hang on. So if we... Okay, so we have the connection. So if I press tab, it's going to crash. But like there's nothing like because I'm not running a thing every frame. I'm running a thing every update. So how do I like not run it every update? Because it's not like I can just do like if thing is. I guess I could try. Well, no, that wouldn't do anything because it's an inf. Like, because it's not that the frame rate is bad, it's that it crashes instantly. Which to me says that there's some sort of probably this. Probably this is causing the issue. So that means. Let's have a variable called like edit or like starting edit. It'll just be like here. Then let's do like if placing return. Placing equals false. Oh, wait, no, placing equals true. And then once we get all the way down and we've finished placing, then placing equals false. Actually, no, we can do that even closer. We can just do equals, like if placing, return. Basically like a critical section. And that way we wrap all of this code up in here. So that way if I have anything that would edit, like count as editing, it doesn't like do an infinite loop. Or does that mean that we have to, yeah. Because this adds the thing here. Oh, wait, yeah, I forgot this. This needs to be up here. Okay. Run again. So, is it printing at all? Oh, wait, no. Window console. Oh, window console. Cannot access local variable placing where it is not associated with a value. But it is associated with the value. That's why I've put it here. There's something really like weird I feel with how yeah, there's something really strange with how Python handles variables. I don't understand this. Like, how would this code not work? Like, we have a variable, and then in a function, we check that variable. Is it maybe because of how Python or Blender, like, loads this thing? Like, if I did, like if we revert this. And then we run this again. So we have sun handler, fog handler, wall check. Okay, good. So we only have 3. Error in unbound local error. So Python. Okay, let's understand let's go back to school. I didn't actually mean to can't delete that, but I guess Python unbound local error variable outside function. Variables that are only referenced inside a function are implicitly assumed to be okay. So we can just do like global placing. Okay. Global placing. So we still have to declare. I hate Python. We still have to declare, like, oh. So yeah, it seems to be some sort of infinite loop or like Stack Overflow or something caused by an edit triggering an edit. Even though that should be checked, that should have been fixed by this. So I don't know. I mean, I just realized that explains why. Oh, wait, no, I guess this is fine. I guess that's fine. But yeah, so now. Oh, wait, no, it's here. This one. Yeah, because we got our pillars, we got our walls, we got our things. Is there something that we can do that would be better then? So called after frame change for playback and rendering after the data has been evaluated for a new frame. Oh, wait, no. Yeah, so the big thing then, I guess maybe we could do like a mode change. If, no, we can't, so that's not a thing that we have. Altering data from handlers should be done carefully while rendering the frame change pre and frame change post handlers are called from one thread and the viewport updates from a different thread. If the handler changes data that is accessed by the viewport, this can cause a crash of Blender. In such cases, lock the interface before starting a render. So this is how, so this is not how, so this is basically an example of code that would cause a crash. So how do we work it then? How do we make this work? Because it'd be very unfortunate if we got this far and this is like where I can't figure it out. But yeah, I think the big issue is that depth graph will be changed by the thing. So what we might want to do is have how would we do this? Because it seems like when we return from this function, maybe what's happening is that this, like then immediately after we like do this stuff, it calls this again because like we've updated the function or we've updated the stuff. So we can print like check. And then what I'm going to do, can I do Blender from here? No. Yeah, if we change anything. Oh, well now it's just, oh, right, because we didn't run it yet. Yeah, you can see it works once. Let's do placing equals 0. And then if placing plus equals 1, placing greater than 10, placing equals 0. So yeah, maybe I'm basically just copying your idea of actually, I've now somehow made it so it does actually update once every 10 updates. Or at least that's the intention of that, if I can figure out if that is correct. Yeah. And we don't even need this. So now, no. Okay. I think it's actually, yeah, I think the core issue must be that this is called from a separate thread like I was talking about, so it just causes a crash. It's not something infinitely running, it's just something, oh, right, you're true. Well, right, yeah, we can just do, what do we do actually? Yeah, you're right. We do this. Oh, wait, actually, we had it here. Okay, let's look through this again. So placing starts at 0. If we have placing, but we don't, so we can skip that. So placing equals 1. So we do stuff. If this causes a change, we do this, and then that. And so I think the main issue is that it's not guaranteed that this will actually, like, prevent infinite looping. I think what we'd actually want is, let's do, like, status equals false 0. So if status 0, return. Elif status 1. Status 1 plus equals 1. Or status 1 will actually equal status 1 plus 1 modulo 10. And then status 0 equals true. Status 0 equals false. So now there's basically, we have both of them. We have if we are in the middle of this context, we return. Otherwise, if we have set status 1, we have to increment this as well. And so it still only updates once every 10 frames, but it does not update within this. And so now we can see, hopefully, once and for all, if it is actually a like infinite loop of editing things within the thing, or if it's a threading bug where it's just crashing. Oh wait, we still need to like reload this, run it. Oh, not quite. Oh, I think I might have changed. I think I might have bugged the logic. Unless it's just, hang on. View, let's do Python console. There we go. Ooh. Okay. Now we can try again. Not quite working. Oh, no, actually, no, that's fine. Window, toggle console. Okay, tuple does not support item assignment. That's stupid. Okay, then just make it an array then. I don't care. Yeah, no, it seems like it's not that. So how do we do this then? So like Blender add object in depth graph update handler. Hmm. Yeah, I mean, that's what I'm doing essentially, because it already checks if we're checking an object that has the correct stuff. Or, wait, where do we check that? Oh, yeah. If we're not doing that, we do this. Oh, wait, I just realized that this actually, so we need, so if, we actually just need if obj and obj.type equals mesh and pillar in object. Then we do wall run. Otherwise, we just set this back to false. Oh wait, but that still doesn't fix the issue. But yeah, so it's guaranteed to be, like, it's guaranteed, I think, that only one of these is running, and we don't get recursively more. So I think no matter how few times I run this, I think it's just a crash that happens because I'm editing stuff inside of the handler. And so I need to figure out some way of maybe queuing events to happen later. Hmm. Hmm. So frame change pre. Blender calculates necessary or successfully meshes on preview but crashes on render. Let's just look up like depth graph update handler crash. Hmm. There's no notification for that. There's only the depth graph notification, which is basically like when anything updates. And then what I do is I check if the object that we're currently selecting is like, well, if it exists, if it's a mesh, and if it has the pillar property. So that means that it's a wall. So presumably, if we have that selected and something's changed, it's because we've edited it. But what I'd really want is, like you say, something where we check a notification for when we stop something. No, 211 is not inside the if. This is what appends. This is just what starts the thing. This is what adds the handler. So adding textures between renders causes that. Hmm. Hmm. So there's something to be investigated by the dependency graph team. There's specific code to ensure pre-post update handlers can modify relations, but indeed deeper look is required. To me, it's a bit confusing why viewback playback or viewport playback works fine. Threading conflicts. Yeah. Let's look up depth graph update post allowed changes. So how can I run it once and it will run it every change on objects until what? How can it be stopped? So if you're stopping it, so it seems like I should be able to do this. So how exactly to figure out what changed in the mesh? What if we just, for now, what I'm going to do is I'm going to have it update every, or in object mode, first of all. Let's see if that happens. So like, if bpi.context.mode, or like, let's say not equals, and just do return here. And we don't need to check here, or we don't need to print that. And then we don't even need, so none of this status stuff seems to be doing anything. So I'm just going to remove all of it. And basically, we'll have it so that this updates anytime we are in object mode. Okay, so that was one update, going from edit mode to object mode. I mean, let's just print. Let's do this. So we can just see how many of these we get. Oh, wait, no, window, toggle system console. So we should have, oh wait, we don't have any of these because we haven't done this. We need to run this first. So nothing there. Go back to edit mode. We did it. Yay. So we have it running where it only triggers on the end of edit mode. Unless we change like this, for example, that also triggers it. So any selection changes will do that. And so what we could do is we could have if was edit mode. Equals false. And then like elif was editing. So now it'll only do this at the boundary condition, and it won't do it, for example, so we can basically revert this. And so now, like, we run this. And so if we click on stuff, it doesn't change anything. Oh, right. We gotta do that because Python wanted to make programming easy. And of course, the way to make it easy is to make things really confusing and require like, well, whatever. Worse is better, as they say. There's a reason Python's popular, and it's because it's bad. But okay, now if we like fiddle with stuff, it doesn't update a whole bunch of times. It only updates the one time. That doesn't fix our underlying issue, but this will be useful. Yeah, now I would like to still try this, but I think this is just going to crash it. Still. Like it does. Okay, actually, hang on. Actually, certainly not as like elegant as I wanted it to be, but like I made worse stuff. And this could be good enough for me. Because otherwise I have to figure out really complicated stuff with the math. I'm surprised that that was the issue. But okay. Now we got this bad boy. And it doesn't even run every single time we do everything. And there would be some very complicated constraint handling, though, from my little brain. But then again, I can just not have, like, 5 nodes all together here. And actually, now that I've realized this, there's not even that big of an issue. We can just do like that. Or like this, and then, like, go right there. Eventually I need to figure out how to get this to do exactly what I want, but... we can basically make it good enough. Because you can see here, for example, we could do like, we can move this here. Move this like this. Yeah, look at that. Now we can make walls pretty easily. And all it took was 2 days of immense suffering and strife. But now I'm extremely powerful. We couldn't get it like running every frame, but that's okay. Because yeah, I think it was something to do with like the mode changing. Which makes sense since mode changing would like do stuff. But yeah, so what we're going to do, we're going to remove all of this. Yeah, I hope it does. It should save a lot of grunt work at the very least. But okay, let's describe it as it is. So the original vision. The actual implementation. So basically, give objects walls and a pillar node. Whenever you leave edit mode, it updates. So basic usage. Object walls and a pillar node. Well, whatever. Yeah, that little adjuster thing. Yeah, that'd be nice. But I'll ignore that for now. Let's go back to my actual task, which was this. Oop. Hang on. Is Blender working? Oh, there it is. Okay, good. Now, this will be powerful. We have a whole wall builder. And what I'm going to do... oh, wait, we need this to be... hang on. Object.name dot replace delete with nothing. So this will be important. Because now what I'm going to do, let's get empty. So let's call this like walls 2, delete. Thank you, Blender, for putting it at the very bottom. So I'm going to put this in stuff, and then we will add a new empty here. This will be zone 2. And yeah, now what I can do, let's just add like, oh wait, no. How do I do this? Plane, walls, 2, delete. And then this will have pillar somewhere in here. Basically like a pillar. So it'll be a little tedious to set these up, but that'll be okay. Wall 1. Because basically I just have to set up as many data blocks as I need. Wall 3. Okay, so these will be like post, simple, long, simple, short. Probably not 002, but I guess it is. Wall 10. All right, let's rename this one to just that. There we go. So now we should have our beautiful properties here. Long, short, medium, that. And then we can do run this. And now the real trick will be to see if it actually like does what I want it to do, or if I've made a fool of myself and wasted my own time. Okay. Hey, look at that. Already working. Let's see. So the real trick will be making them like cooperate with each other. Or making all of the walls like align nicely. Yeah, now we're cooking with portals. And eventually I'll probably replace some of these with this system. But for the time being, these will be perfectly fine as they are. Just try to figure out who do we want to be. What I'll do for now is I'll just put in the walls and then I'll do the constraint solving later. But yeah, this should make stuff like this a lot easier. Though our main constraint now, I'm realizing, is they don't like perfectly align with the ground. because that'd be a much more difficult problem to solve. So I'll just have to like figure out how to make that work. Ah, well. It basically works good enough. And to think, yesterday this would be like 25 minutes of just placing walls. Now, life has never been easier. The fruits of our labor for us to enjoy. We own the means of our production. Oop, there we go. And we can even do things like duplicate. And it'll just work, hopefully. I wish there was a way that I could see the vertices. Oh wait, I just realized there is a way I can see the vertices. No, there isn't. Never mind. So yeah, now the only issue will be all of that constraint solving. Wow, look at me go. This was, yeah, this was genuinely would have been like 20 minutes of very boring, very easy work. But I could replace it. All I needed to do was like 6 hours of very complicated work. All right, we don't need this here. And I'm thinking Arby's. Eventually I'll need like, I think I'll just need like really tiny wall segments as well. That would make a lot of sense. You know, just add like a 1 meter segment. Actually, that'd be just about perfect. It'd be a bit obvious when I was using it, but I mean, oh well. You know what? I'm gonna merge these. We lose a bit of the soul of it, but it does make up my job easier, and that's great for me. Yeah, I think you have a point of maybe like a little segment here, or like we'd have just some final wall piece that can grow and shrink. I wish I could just scale things and have it work in Godot. Mm-hmm. Yeah, now we can just slap walls in. Delete all of these. Uh, and yeah, I'll clean up the, should I clean up the constraints now? I might as well. It shouldn't be too hard, because I think the way that I'm going to go about it is basically we go to each of these, and we can just kind of push these until this endpoint is where I want it to be. And we just do that wherever there's a problem. In fact, we don't even need this one. We can just delete this edge. Oh, the one downside, though, is that the way that I've designed it, it basically keeps the longer one. I have a good idea. Get min size. Shortest divided by 4. And then let's revert here. Or let's save. Ooh, actually, will that cause circular issues? No, it won't. Okay. Okay, now we revert, because I think what I need to do is I need to run this again. And then this should be a bit better about like updating responsibly. There we go. Okay. Yeah, I think that's good enough. So that fixes that side. So now I need to figure out like how to do, I basically did this in the opposite order. Yeah, that's good enough. That seems okay. And hopefully I can make this work without it feeling too obvious that I've been fiddling with these things. And this one's okay. This one's a little long. All right, let's see. Ooh, hang on. Interesting. This wall is slightly different than how I want it to be. I want this to go down a little bit more. Ah, well, let's have that be as it is. Yeah, walls growing and shrinking would be very useful for just making it like where I don't have to do this like constraint like fiddling. But until then. Because I'd basically want how would I do that actually? How I'm trying to think how would I want to do that? What I'd really want is for the physics engine to just work with scaled objects. Yeah, true. I think we could make it work with growing. Well, actually, I guess you could take the minimum object and shrink that, and that'd work. Or you could take the longest object. You could just decide. I guess it wouldn't be too difficult to decide which one you want to do. Ooh, this one's gonna be tricky because I wanna figure out how to make this match up nicely with this. And I think what I might do is just make this not bother. Oh wait, but then it has to. I think what I actually want, get the slope and make that a bit more, I think this needs to be a bit less generous. Yeah, I'll just place doors on the walls, I think, for like holes. Because yeah, otherwise it'll be complicated. I'll have to figure out how to like mark certain areas as having holes and stuff like that. It'd be too hard. I'll just do it easier. Is this really 0.75? This doesn't feel like it's doing what I want it to do. But let's say that's probably fine. Oh, wait. Except for this area here. There we go. So now you can see the walls are a little funnily shaped. But I think it'll only be if the player's really looking close. So yeah, they're not quite as pristine and precise as these ones. Because these ones I could... Well, actually, we can just have it so there's no inner pillars. Because I have it here, like, if not, or if inner, not in, you know, let's just do like, if inner pillars, place pillar. So this is our inner point. Actually, elif inner pillars. And that'll just be all the way at the top. If so inner pillars equals true. If inner pillars in obj, inner pillars equals obj. Oh, wait, yeah. It does that. Okay, so now what I'm going to do is I'm going to have inner pillars here. Well, let's... What would I want to do? I'm thinking I duplicate this. And then we delete everything except for this vertex here. Because this is going to be like walls, other walls. Oh, wait, I just realized this. I don't know where the sisters are for this. Ooh. They're not in the right place, but that's actually okay because we can just like move it. Oh, we can't quite just move it, can we? I'm sure we can. Hang on. I don't get it. What's the issue here? Also, why is it like, oh, I see. Because this is a duplicate. So we need to remove that. And then we can come back to here, do that, bring the walls back here now. It doesn't create the sister. It does create the sister. Okay. It's just not working. Where is it? Okay. Trace back. Skipping vertex. So list object has no attribute data. Oh, what if we remove wall pieces And then we have this in here. Okay, yeah, I forgot to do this. Oh wait, no. We should be, that should be fine. There we go. Everybody clap. Oh, and this one I wanted inner pillars. There we go. So now, I'll figure that out soon. Basically, I want inner pillars to be an option that I can set on and off. Since now we're not going to have the like pushing and pulling thing with the pillars. Since that's just too complicated for me to figure out. Maybe someday. Let's see, anything missing here? Yes, there is. I don't like this. I think we just do simple like quads. Yeah. That looks about right. And then the next step will be getting these working the way that I want them to. And that's going to be very strange to figure out. But okay. Duplicate this. Oh, wait. Remove the sister, and the wall pieces should be the same, so that's fine. Actually, let's just do like a square. I'm trying to figure out, okay, cursor to selected, cursor to selected, cursor to selected. Okay, faces only. Now, this thing, where's this thing? Oh, this should be walls 4. And then what we do is delete sister. Surely it'll work at some point, but maybe not yet. Maybe we need to also delete the pillars. Okay, good. Why do we not have this? Remove the sister, remove the wall pieces. Boom, it's back. We got both of these. Not sure what the deal is, but that's okay. Because now... Oh, wait, I need walls 4. Hmm. So now we'll really be a slave to our constraint solving issues, which will be unfortunate, but that's a price that I'm willing to pay for not doing too much work. Because admittedly, the walls here are especially bad. Eh, what do I want here exactly? This? Yeah, that's good enough. Ooh. That's unfortunate. It almost worked. Just how I wanted it to. Okay, that's good enough. All right. That looks practically good enough there. So we'll keep that there. Then we'll do God knows what to get this connecting on this side. Oh, not even that bad. Really, the only issue that I see here is this part should be lower. Oh wait, does that? Oh, okay. That looks. It could be worse. Hmm. I guess that's good. Put that there. Put this there. All right. Why is this not? There we go. Okay. Oh, but it's way too far out. So we do have to have it down here. And that means that we have to have it further down in order to keep this There we go. Okay. I kind of like this being open. I'm going to keep that open. And then what I'm going to do is, honestly, just copy like an edge here, or like vertices. And then we're just going to use these for the rest of them in this little area. But okay, this has already saved us probably like 2.5 hours of like placing these little pillars, I'd want to say. Admittedly, there's still some things that we'd need to do to make it really shine, but I mean, sometimes bad work is the work that you do. And I say, nay. I will push this in. That's about right. All right. And I'm wondering if I should go back through and like redo the other walls with this system. Well, I don't want to bother. Especially these, yeah, because these ones are already like, I spent a lot of time laying them out pretty precisely. Because now it'll be really easy to swap them around, but how many times am I going to swap them around? Oh, wait, should I? Oh, these are interesting. I don't know how this, oh, I think I just didn't edit them yet. Okay. Oh, wait, yeah, some of these are actually just, like, really off. Okay. Oh, wait. Delete that edge there. Boom. Now it makes way more sense. How do we fix this? Eh. Oh, I just had a good idea. Just bring all of this up. And then bring this way. Uh, yeah. Boom. And that's what we in the biz call good enough. And then last, and probably least, can we control B bevel? No. But Ta-da! Let's get it right where we want it. And then we can fiddle with the constraints. Yeah, thank you. I'm glad this is being useful. Let's see, so I think this one will be tricky. I might just want to place a wall manually here, or... I know. There we go. And do I like this wall here? Because what I think I could do... we could have this here. And then... oh, I see. These are two different parts. Okay, that makes sense. Do I want to do something different then with this? I think I do. It's just going to be delete this little segment here. Wait, hang on. Did I, like, scale things? I think I scaled something. Like, if we look at these objects here. So this object scale is 1. Okay, interesting. But these are clearly different sizes of object. Am I missing something? I guess I can just try them out in Blender and see how I feel about it. All right, we don't even need this anymore. Or did I say Blender? I meant Godot. Whatever I said. But yeah, I have no idea why these are different sizes. They're very, very clearly different sizes even. So is there... Then actually looking at this, it's very alarming that this one is so different. And also, I didn't realize that it actually shows me which parent this is, so that's useful. Yeah, okay, let's see if this even works, because if for some reason the scale of the objects is broken, that's going to be unfortunate, because I have no idea how to fix that. But I mean, I guess, it's just, there's 100% a scale size difference. Like, these are, they're just different shapes. When did this happen? All right, but let's see if the walls actually work. Crab Hill Farms will be rather tricky to figure out. No such entity. Ooh, I'm seeing. Oh. So what I need to do is probably split off the, yeah, let's go to my importer. Wherever that is. Default importer. So when we get the name, so plain name equals n.name.split dash 0. So if we try that now, actually, let's push a warning. Okay, re-import this again. Okay. Plain name. Oh, why do we do this? Oh, I see. We actually need this here. So plain name equals plain name substring, get the digits, etc. And then path elements equals plain name split that. Okay, try this again. There we go. We got hundreds of errors, but no warnings, and that's the important part. But now we should have a billion beautiful little wall pieces. There we go. And they're not even, I mean, there are different scales. Hang on. So we'll have to figure out where they become different scales. Because surely something, somewhere. Oh, wait. Oh, I see. Okay. I mean, I don't really see, but I'll see eventually. It'll come with time. My music died, of course. But yeah, our next step will be patching up all the holes, making it all sparkle and spick and span. Oh, wait, I realize exactly what it is. Wait. Oh, yes, I do. Hang on. If we go to the walls individually, okay. That was my blunder. Because it copies it doesn't have the transforms changed because it copies the transforms as a constraint. So therefore it would be hidden. So now the question is, where do we go now? How do we go now? How do we continue on? Good enough. Oh wait, I see what I want to do. Oh yeah, I guess I should, well, do I actually want the line to stick to the ground? Because I could just do a shrink wrap modifier on this. You know what, that's a good idea, actually. Add a modifier, generate, no, I think it'd be modify? Deform, maybe, shrink wrap? Then we're gonna do like -2 meters right on this bad boy. And that way, I should be able to, oh wait, but it gets the actual vertices. It doesn't get the modified values. I don't think. Wait, why is it like this? Hang on. Yeah, okay. I think that doesn't work. Oh, wait, no. It should work. It's because something's going wrong with my terrain. Terrain center. There we go. Okay, but it doesn't actually respect it. Yeah, the modifier won't work because it actually reads the vertex data directly. I mean, I guess I could figure out how to get modified geometry. That would work, probably, if I was smart enough to do it. But I've already done all my big brain stuff for the day. I don't want to do more big brain stuff. What I'll do instead is I'll figure out all these constraints. Or maybe ignore them and pretend they're intentional. Thanks. I'm going to move this one down. There we go. Here, let's move this one up. These two down. And then these two, I kind of like these ones actually, as they are. And now let's go to rendered, so we can see where the holes are, where the gaps are. Aha. Hmm. And then, where were the other little bits that were causing issues? They were in this one. Yeah, I wish there was a way to just like, oh, we actually can see these through this. This is exactly what I wanted. Let's dissolve this vertex. Yeah, that seems about right. Yeah. I was trying to figure out how to do that, but I'll have to figure out how to get like the to read the like modified vertex data and stuff like that, and that'll be more complicated. Let's see, do I want this to be, I think what I'm gonna do is on this side, get a medium length pipe or thing, just slap them together. Oh, we already had that, I think. Well, then we'll figure out how to make this work. I just realized the easy way to do this is to go into Shift Z, so that way I can just see everything. But okay. Anywhere else, I need to do, let's go to rendered actually. There we go. Now we're seeing between the lines, between the walls and the floors, because we have cast shadows enabled. So that means we don't need, for example, this one. Okay, this is exactly what I want. Because I think now it's about right, at least in this little area. Hmm. Oh, I see you. Yeah, there we go. So yeah, I think I will list this as or I will deem this good enough for now. Unless I see any actual, like, gaps. We'll just go, like, a once-over. But okay, I think this is promising. My next step will be buildings, and I might do procedural buildings now that I know some of the, now that I have an idea of how I could do it. Because it'd be nice to be able to just, like, specify the size of a building, run the script, and then we just have a building of a particular, like, dimensions. But I guess the alternative is to just make the building pieces, like really tiny pieces, then prefabs and other things. Yeah, I'll have to figure out how I want to do that. Oop, I see. More subtle flaws. Small enough that only I can see them. Hmm. Hmm. Yeah, I think the rest of the wall gen, the like shrinking things, modifying things like that, will probably get more, it'll probably get like exponentially more difficult to figure out. So why are these not named? What are these from? Huh. So these don't have names for some reason. Well, I'll ignore that. No need to look a gift horse in the face. Well, no need to look bad naming convention of automatically generated nodes too closely. But yeah, there's definitely ways I could improve the wall gen, but they'd require automatically generating meshes or the much more complicated algorithm for placing the objects where it takes advantage of the pillars and things like that. And that'll be just too complicated for me to figure out. So what I'm going to do is not figure it out, and I'll just deal with these. Oh, wait. We still have some, whatever. I'll basically polish up, like, issues like this. What I should probably do is have the pillars, or give the pillars a distinct material with a fixed color. So that way it's very easy to tell where they are relative to the walls. Yeah, so you can see there's little bits of things that aren't polished. Hmm. Should I do more? Now, I think what I'll do next is I'll start on the buildings now, and then we can do more decorations and stuff. Because, yeah, we only have the fancy olive trees, but now we need, like, just regular old trees. Thanks. Yeah, it definitely makes it easier to make just a lot of stuff. Though, admittedly, I am thinking, is it interesting stuff? I guess it's fun to climb on the walls, and a lot of this is more meant to be just, like, almost set dressing, or, like, just stuff you run around on without engaging with too much. So I guess it's fine that it's, you know, just walls. They're not too crazy. They're not too fancy. Hopefully I'm not seeing frame rate drops from touching these. Because these are only like, these are all like cubes internally. So I'll just assume there is some other random like frame rate hitch. Because I have found that some of my trees are still too detailed, where like when the player stands on them, the frame rate dives. Yeah, we'll just keep our eyes out for things like that. But okay, what's our errors? For whom does this bell toll? Let's just save this. Okay, that'll probably be it for today. I started quite late, but c'est la vie. I don't want to stay late. All right. So wall generation is good enough for now. Now let's get commit AM for this one. Oh, wait. What did we just change? 14 files changed. Oh, I did a bunch of bug fixing that I forgot to apply. Oh well. Yeah, I think once we get into Crab Hill Center, this change is going to be like, or this new wall generator will actually be really useful. And I should probably make all of my Blender scripts open source. That'd be nice. But okay, that'll be it for today. I will be back on Sunday, for more video game. And we'll probably start on buildings and then more decorations. But thanks for stopping by. See you later.